Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2010 Mercedes-Benz GL450. This Mercedes has misfires and it's running bad and it's setting lean codes. So we're here to take a look at this to diagnose it properly. The fuel pump in this vehicle, the whole assembly has already been replaced with a factory fuel pump and it's still running lean. So now our job is to find out what's really wrong with this car and diagnose it correctly. So the first thing I want to do is get a scan tool in this car and go for a test drive and gather some basic data so we know how to diagnose this car when we get back over here. So let's jump in the car and go for a test drive. Okay guys, I got the scan tool connected. Let's take a look at it. So right away I can see I have a big fuel trim problem at idle. Bank 1 is better than Bank 2. Bank 1 is orange and Bank 2 is red. This is long term and the bottom one down here is total trim. So we have a trim problem just sitting here idling. We have RAF sensors, the stoichiometric and center. This tells me that the fuel trim's correcting the problem and I've got good control with a center symbol. The stoichiometric tells me that this is a RAF sensor. And I know I have a big fuel correction problem. Notice bank to bank trim is 4%. That's quite a bit from bank to bank being a problem. Time to temperature, I'm 188 degrees. The engine vacuum is 15 inches, and that's okay. I'm a mile high. I'm in Albuquerque. So 15, 16 inches of vacuum is what I expect a motor to make. Charging voltage is good, 14. DTCs, we have 6 DTCs set and the monitors have been run, so the shop did not clear the codes. If they did, they drove it enough to run all the monitors again. So let's look at the codes. So basically we have system 2 lean, bank 2, system 2 lean, bank 1. That's what we're here to look at. We have random multiple misfires. That could be caused by this being too lean. So we don't want to start looking for misfires until we fix the lean problem. And then we can see that we have codes for missing cylinders on 1 and 5, and we have an injector circuit malfunction. Now don't get caught up in a code like this because I'm working for another shop. They might have unplugged an injector. That might not have any validity on what our codes are. So what are we doing here? We're looking for a lean condition and it's lean enough to make it miss. Now the shop says that sometimes this car runs really, really bad and it just misses. Now I don't know what it does because I haven't driven it, but we'll see. Right now I don't feel it missing. The next thing I want to do is I want to go over to mode 6 and I want to just run a quick test. I want to see what cylinders mode 6 says is missing. So we'll just run it in generic and it'll find the cylinder misses for us and then we get a better idea. So we're going to come down here and we can see that cylinder 1's missing, cylinder 2's missing, and cylinder 5 is missing. And 2 is missing way more than 5, but 2 didn't even set a code for the misses. It was 5 and 1. But we got multiple cylinders misfiring, and that's okay because I think it's so lean we're getting misfires. So we don't want to start looking for misfires till we fix our fuel control problem. So the first place I want to go is the sharpshooter in the eSCAN, and I want to pick total trim, long plus short, and we'll start it and we're going to load these graphs. And we can see that if it's red, it's bad, and if it's green, it's going to be good, and if it's orange, it's pretty bad, and yellow. So the way this works is green and yellow are okay, and orange and red are broken. So this is broken, as we can see. They're red. So now what we want to do is we want to go ahead and we're going to drive this, and we're going to fill this chart out. Now this charting, as you're going to see, makes this car, it's going to be way easier to diagnose this car. But we're going to just go around the block and we're going to be able to diagnose this car. And these guys, this is the second shop that's had the car. So it's not an easy car, but let's see what we get. So we're going to get in it. It didn't pull real good there when I got in it. I could feel it like just not pull good. And I wouldn't doubt it because everything is red. It's broken, right? And we've got a lot of trims there. Like that's a big trim number. So let's go ahead and we want to get just a few more trims. Yeah, it definitely doesn't pull good, guys. It's just not pulling real good. Definitely doesn't feel like the car like it should pull. It's just lacking some power. But I can believe that because the trims are huge. But what that tells me is we don't have enough fuel control, enough trim to fix my problem, or it would run okay. So now is what we need to do, is I need to run a volumetric efficiency test. Now what this is going to do, so let's go ahead and start the test. Let's set the temperature for our temp of the day. It's a 4.6 engine and we're at 5,500 feet, so all that's good, so now we can run it. Now what this test is going to do is it's going to compare the actual mass air sensor to an engine model that's programmed into this. What I want to do is make sure it's not something being read wrong with the mass sensor, and that's what this is going to do. So we roll along and we floor it in first, and we let that graph up, and we can see that it didn't quite follow it correctly. So let's just stop here and look at this real quick so I can see what's going on. Okay, so we can see the yellow trace is actual reading and the red is what our map should be. They're really close. You see how they're fully open, they're green, they're good, and we're off a little in the middle, but we have big trims up top and on the bottom, and this is saying we're okay, except for right in the middle, we separated a little bit. Now, to get a better idea, go to power, and the power is given right here, and we're going to match horsepower. Now, the horsepower is matching it wide open, so the overall air going into the motor can make the right amount of horsepower. So the air is being read right. If you're not sure if the VE, this is scaled, so this will read this engine correctly, but I always like to go to power, and then we're figuring the horsepower based on the air. And here we go. We can see this, that we came up and we made the horsepower that the factory says the motor can make by air, but it's not taking in the fuel control. This is just saying I pumped enough air to make the horsepower. So I'm pumping enough air and I read enough air by the VE. So now is what I want to do is I want to go to the compare table and I want to run these two. Now I want to show you something. This blue one is the air reading, and you see how it's pretty flat? Do you see how we're going from 20% to holy 60% trim adds up here? And that's more than most cars will give. 60%, 50, 60% trim is as much as I've seen. You don't get much more trim than that. So this is not an even curve. You can see that I went from 20 to 60% trim. And do you see how flat my line is for air? Well, if the air is the problem, it's going to have to match this curve up here, and it doesn't. It's all flat. So this tells me right now that this is not on the air side. So guys, this is not on the air side. This is something to do with the fuel delivery system. It's nothing to do with the mass sensor or the way the computer is reading the air. This is the fuel delivery. So this is a delivery problem for sure. So now, I haven't even made it halfway around the block and I already know how to diagnose the car. We need to go get a fuel pressure gauge on this. And I'm not sure, but I think these guys give me a fitting. I don't work on a lot of Mercedes. I'm sorry guys, I'm no expert on these cars. I'm just the expert on how to diagnose the car. I don't know every car, all the cars I work on. There's just no way I could know all these different cars. But I've done some on these and I believe I have a fitting, and I hope I do, so it's an easy test. So what we're going to do is we're going to go back to the shop now, and we're going to, here, let's go, shut this on, back to PIDs. So here we can see our numbers over here from our trims, and we can see what it's doing over here. We can see they're all red. Red is broken, guys. And what do we know is broken? The fuel delivery system. And I haven't been driving this car for just a couple of minutes. That's the advantage of using a scan tool like this. The eSCAN is the only tool on the market that can do all these kind of tests for you. This is a patented technology scan tool. If you want to diagnose cars really fast, this is a great tool for it. Right there, it almost felt like the engine was missing. when I pulled away. It didn't feel like it pulled right. So right here we can sort of take a look as we're driving, and it gives us a different look. But what's really important is the way we plot the graphs, and we can compare those graphs out to figure out what's really wrong with the car. Because a problem like this could either be in the air side or it could be in the fuel side. And that's all I'm trying to figure out right now. And now I can see that the problem is on the fuel side. So I always like, when I'm on a test drive, I like to know what I'm coming back to the shop to test. If you don't know what you're testing on your test drive, you need to keep driving the car until you know what you're going to test. Otherwise, you're just wasting your time. Okay guys, I got my pressure fitting right here, and it does have a pressure fitting on the rail just like I thought, so I'm really lucky. I'm going to use a pressure transducer on this, so I brought this up. Now before I put the pressure transducer in, we want to set that up. So I've got it plugged into the scope on channel 1. We're going to go to a 300 pressure transducer. So we're going to pick the transducer, and then we're going to zero it, and then we're going to come over, and we're at 0, and I didn't plug it in yet because I don't want fuel pressure on here before I zero it. So now we're going to plug this guy onto the rail, and obviously I don't know if that's not enough pressure, but it's not running either. We have 21 psi. So now is what I want to do is let's go ahead and start this vehicle up. Okay, so we're running, and we only got 36 pounds of fuel pressure. Now that's too low, guys. So we've already got a lack of fuel pressure. What I want to do now is I want to go to where we're graphing. Oh wow, look at that, guys. That's cool. We have a problem. It's like the line's restricted, I think, but I'm not sure. But usually when you see this, it's an indication I got a restriction. Do you see how the fuel pressure is dropping? And that's dropping almost 6 pounds. So every time an injector opens, it drops. That's a bad supply to those injectors. Almost every time I've seen this, there's something wrong with the line where it's restricted. So what I want to do is I want to go ahead and I want to snap the throttle real quick, and we want to see what that's going to do. Okay, we can see right here where we're dropping pressure every time an injector opens, but when I rev it, look at our drop. Build up. The injectors aren't pulsing right here because we're in a fuel cutoff, right, from decel. That's why you don't see this. Now we open it up and it drops again. We're dropping the fuel pressure. It can't maintain the volume. Okay, so I got the pressure over here running, and you can see every time I open an injector, I'm getting a drop. I want to do something else. I want to open up my rail, and I want to see how much fuel is able to come out of this. Okay, it seems like quite a bit. Look at how aerated it is, guys. Okay, guys, so we're going to need to get to the fuel pump. Okay, guys, I found the pump. It was underneath the passenger side rear seat. In order to access the pump top where I can get an amp clamp and a power, read the power to that pump, I had to remove the seat. Now removing this seat took longer for me to get the seat out there than to diagnose the entire car. So that's crazy. But you got to do it, because without the data from that amp clamp, I cannot find what's wrong with the vehicle without that. So let me show you what I got here. So this is the pump down here. I've got my amp clamp on the red and white wire, and I got my blue trace in the red white wire, and I got my green trace on the ground. So that'll give me the power, the ground, and the current. Now the current's the one I really need, but I always want to check the power and ground as well. So now I've got the scope here, so now let's get a reading on the scope. Okay guys, I got the scope set up. On channel 1, yellow, I've got a pressure transducer. On channel 2, red, I've got an amp clamp. On channel 3 and 4, I've got the power and ground of the pump. So let's come over here and make sure. So we're in everything. 37 pounds is too low. We've already covered that, but that pump is full of air. So this is the pressure, this is the amps in red. That's the one I'm interested in. Now guys, is what I'm going to do is I'm going to bleed some pressure off like we did before into the little can. And when we do that, we're going to drop the pressure back there, and then I can check that. Yeah, that stitch is full of air, guys. Okay, now you can see where I open it up and it's flowing into the jug is right here. My pressure's dropped almost just a couple of pounds and then it rose back up. So I can't maintain pressure. What I want to do here is I'm interested in the amp clamp. So we're going to get the zoom window and we're going to come over here. We can clearly see we have no pressure here. So now's what I want to do is I want to get the cursors. I want to come across and I want 8 commutators. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. I have 84 hertz. So take 84 and multiply it by 60. That turns it into revolutions per minute. That's revolutions per second. That's revolutions per minute, 5,000. So basically I have 5,000 revolutions per minute with no pressure. Okay, so now we want to go back out, and now I want to take the zoom window over here and I want to check this where we have pressure. We want to do the same reading. So we're going to get 8 commutators. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I got 79 hertz. Okay guys, I can already tell you the line is plugged. It's not cavitating. Let me explain this. So we want to take 79 and we multiply it by 60. That's hertz. So I went from 47 with pressure on it to 5,000 with no pressure. Now with no pressure, the pump should have gone up to 8,000 or 9,000 because there's no pressure. It's not being loaded, so as soon as the load comes off, the pump takes off and goes faster. Now that pump never went faster. That means that that pump sees solid pressure against it. If it went down to 2 psi, the pump has to go faster. In this case, the line is plugged. So from this, somewhere from the tank to the engine, that line has a restriction in it. This is restriction. And the aeration is just as it's going by the restriction, it's cavitating because the line is partially restricted or kinked or whatever's wrong with it. But you could put as many pumps in this car as you want to and you're not going to fix this problem. That's why I'm here at the shop, because I put a pump in and it didn't fix it. You're going to have to, before you guys put a part in, test it. Get a scope. Get some data. Use data to drive your diagnostics rather than hanging parts. You're going to be way, way more successful using data. But right now I know what I got to do. We're going to have to come back and I'm going to have to get a lift and we'll raise this car up, and then we're going to need to check that line to the front of the car to where somewhere from where that pump is, from the top of the pump exit to the engine, that line is restricted. So we now know that the line is restricted. That's a huge gain, because if this was cavitating, this pump would be all over the place. When it gets air and it's cavitating, it'll go up to 7,000, 8,000 RPM, and then it will load again down to 4,000 or 5,000. But the pump moves up and down, and that isn't what we see. You can see that really easily here. Let me go back out and show you what I'm talking about. Do you see how the current stayed level all the way across? Even though we don't have pressure here, there's no pressure here, and then we got pressure, the current draw to the pump didn't change. That's because even though the pressure at the motor, where we're checking the pressures at the motor, well, we're on the other side of the restriction. The pump just sees solid pressure against it. So this is a really good test so you don't waste time. Now we know we need to fix this car, and we're going to need to look at the line for being restricted. Somehow it's kinked or blocked. So I'll come back and we'll get that done. I need a lift, and we're going to need to pull some panels from underneath there, I think. I think that whole line's covered. On most cars it is. So we'll come back and we'll take a look at that. But right now, we can clearly see what the problem is. And like I say, you can put as many pumps in this car as you want, and it's still never going to fix the car. You're going to have to be able to diagnose a car in order to find a problem like this. I've laid out an apprehensive plot that I've shown you right here, how you diagnose a car like this. Okay, so I took the top of the tank off and I pulled the line, the crossover line off, and we've got a hose directly on the outlet of the pump right there. So that pump has now got a hose directly out, and we're going to flow it directly out of the pump. We're going to see what we got. Okay guys, so this is 1,000 milliliters, so this is about a quart. And with 42 gallons an hour would fill this in about 30 seconds. Go ahead and crank it. We'll easily fill it in 30 seconds, guys. We're almost filled, and that's 20 seconds. Go ahead and stop. So that's 20 seconds to fill it. So that's more than enough. That's 42 gallons an hour right there. Okay guys, now we're going to check the outlet that goes to the engine out of the tank, so it comes out of the crossover. So now we're going to test that. Go ahead, crank it. That's good. So that's 15 seconds. The other side totally filled this up in that same time. We're getting half of the fuel delivery out of the outlet. Now when we came directly out of the pump, it filled the container totally within the 15 seconds. That's 15 seconds, and you can clearly see that it's half. So we have a restriction, and it's got to be in the crossover from the pump to the outlet, because that's the only place it can be now. Okay guys, so this is one of the problems with not being an expert on these type of cars. The line goes from the driver's side, the fuel pump, out, and it comes to the passenger side, and it goes into a fuel filter and then comes out. The fuel filter is what's plugged. So the plugged fuel filter is the cause of this problem. Okay guys, is that one crazy Mercedes-Benz or what? Wow, what a pain. What a pain with all the seats and getting into the tanks. It took me longer to get into the tank than doing the whole diagnosis. Now, what's really crazy is we could see that we had a restriction, and we could see that we weren't fueling correctly by using the amp clamp on the pump. It's an extremely effective way to diagnose cars. Now in the end, we can see that the fuel filter is all the problem was. Now the shop that got this car is from another shop, and the other shop has replaced the pump and put a fuel filter in. That's what they said, but they never put the fuel filter in. So then you start backtracking, and you gotta, the way to believe is just don't believe anything anybody says, whether it's a customer or whether it's another shop. You just don't know what work was done until you're verifying the work. In this case, this car just needed a fuel filter. That's all that's wrong with this car. You guys have a great day.